from there. Okay, so let me just record this one. Okay. 刚刚我有 send 一个 document 在那个 group， 你可以 refer to 那个 document。那个是 exercise so we're going to discuss that document right now. It's all about finding the frequencies, wavelength, and the speed of wave. Okay, 来我们看这边。So frequency, wavelength, and speed of wave. Okay, so usually question will ask you like this. Okay, give you a waves, ask you to find frequency, amplitude, and the waves. So today we'll learn about how to extract the information from the waves diagram. Okay, now number one. Number one, so here, okay, 首先我们先讲找 frequency 先。Okay, 讲找 frequency. Now 我们已经是学了frequency 是so far you should know frequency is F equals to the number of oscillation 除时间，对吗？ Okay, number of oscillation in 1 second, right? 就之前我们你们不是有做那个 pendulum experiment？ 我不知道你们有没有做那个 pendulum experiment 老师会教你们算 ，OK， 你换不同的那个 length of the pendulum and then you count how many oscillation in 1 second, right? That one is to calculate the frequency. So number of oscillation in 1 second. Okay, so again, oscillation, what is oscillation? To and from motion. Okay, to and from motion. So a pendulum, it can be anything. Let's say a pendulum flow up here. Okay, it swings up here and then it swings back to the other side and swings back to original position. That is one complete oscillation. Okay, it must swing back to its original position. Okay, so that is one complete oscillation. So frequency is the number of oscillation 在1秒. Okay, now remember this idea. Now from this wave diagram 我要找 frequency, so 我要先算这个 wave 是多少个 oscillation. Okay, so 在一个 wave 里面crest 就是 the highest point is we call the crest, right? The crest, so meaning that this X mark is the crest. The crest between the crest, the distance between crest and crest is called the one oscillation. Okay, it's called one oscillation, one complete oscillation, or it can be the distance between here 0 and here. It looks like a wave sign. So from here to here, this one is also one oscillation. So depending on where you look at it, 如果你的 wave 是这样子，这里是 okay, let me highlight for you. So here is one oscillation, or it can be from the trough to the next trough. This is also one oscillation, or it can be the crest to the next crest. Okay, so different ways to look at it. First, you have to know how to look at the number of oscillation, because if you don't know how to look at the number of oscillation, then you cannot find the frequency. Okay, so here we look this one from starting from here. Okay, so until one sine graph, this is one oscillation. Now the rest of the graph are here until here to here. This is only half a oscillation, right? Because one complete oscillation, if I extend this one all the way to here, now this looks like one complete oscillation. So if only until here, then meaning that this is half a oscillation. This is half of one sine wave, right? So this is 1 plus half, 1 plus half. So you have 1.5 oscillation, 1.5. Okay, now 答案不是 1.5 先是 1.5 oscillation 吧？我们有 1.5 oscillation, complete oscillation. 然后过后你要看那个时间 ，OK？ 那 1.5 oscillation 在多少时间里面？2秒，对不对？2秒，对不对？所以我们是 1.5 除2，所以放 1.5 除2，就是 0.75 了，对不对？ 0.75 that is my frequency. Okay, that is my frequency. So I write 0.75 hertz Hz. Okay, amplitude. straightforward, right? You look at your y-axis， 你的 y-axis 是 displacement 嘛，所以你的 amplitude 是5了。It must be the same 啊。Top displacement and bottom displacement is the same 啊 ，just one is negative。But amplitude 我们不写 negative 的 ，OK， 我们直接写一个5。Be careful with the unit. So it's 5 meter. Okay, it's 5 meter. So 5 meter over here. Okay, example 2. Example 2 now, another one. So here, how many frequency of this wave? So we are going to calculate. So here, starting from here, one oscillation, and then the second oscillation. Now, up until here, 这里到这里呢，是多少个 oscillation？ 这里有没有 ？OK， 如果我画这个整个 complete 的 wave 啊，你可以这样子看啊，你看这个 wave 是，我把它分成4个 section 4个 section。So I have section 1, 2, 3, 4. Now this one, the last one over here, is only 1/4 of the wave, correct? 1/4 only here, only the red shaded region. So this one is this one. So it is 1/4 of the vibration. 1/4 of vibration, meaning that this one is 1 vibration, 2 vibration, and plus 1/4. 1/4 is 0.25. Okay, so 2.25. 2.25 oscillation. 2.25 oscillation. Now 2.25 oscillation in 3.5 seconds, right? 3.5 seconds. So it's 2.25 to 3.5 divided by 3.5, and then you get the frequency. So the frequency is 0.64 hertz. Amplitude 10 meter. Just write down 10 meter. Next example, example 3. Okay, one oscillation. How about this one? 这里到这里是 2 oscillation. Okay, so without this one is 1.75. 1.75. Okay, so if you look at one complete oscillation, again, I divide it by 4 sections here. And I shade this region over here. This whole region plus this one. This one is 3/4. 3/4. So meaning that this one and this one is 3/4. 3/4 to 0.75 plus 1 oscillation. The blue one plus the blue one. So you get 1.75. 1.75. Okay, 1.75 oscillation to 35秒. Okay, in 35 seconds. So we divide by 35 seconds. Divide by 35, you get 0.05 hertz. 0.05 hertz, and the amplitude is 15. 15 minus 15, so just 15. It's always the same one. The crest and the trough, the amplitude is always the same one. Unless you have damping. Okay, later I will talk about damping. Unless you have damping. Okay, example 4. Okay, now here, this one, how many vibration? Okay, one oscillation is like this, right? This one is one oscillation until here. So if you only have until here, this is like half. A semicircle, only a half a vibration. 所以它是 0.5. 虽然你看到好像很大这样的，比起之前的那种 diagram 可是它只是 0.5 oscillation 罢了。Okay, 0.5, 0.5. So frequency is number of oscillation divided by time. So 0.5 you divided by whatever the time taken here is 0.25. 0.5 divided by 0.25. So you get frequency is 2 hertz. Okay, 2 hertz. So you should be able to determine the frequency for all types of graphs. Okay, back to the same concept. 你算有多少个 complete oscillation, then you divide by the time. Okay, so here are 4 different examples here. If you don't understand, let me know. Okay, let me know in the chat. I'll repeat it again. Okay, next one. The next question. Okay, example 5. Example 5. Okay, so the wave started here. This is the crest, right? This is the crest. The wave started here. So the one crest to the next crest. The next crest is over here. That is also one complete oscillation. So this is one complete oscillation, and this one is just 1/4, right? 只是一条线这样子 curve down. 1/4, 0.25 oscillation. So this is 1.25. 1.25 divided by 1.2. Okay, so I already sent you this worksheet. Later you can fill it out. Okay, you can fill it out later. You can take a screenshot first. So 1.25 divided by 1.2 是1.04 frequency, 1.04 hertz. Okay, another one, last example. Last example. So this one, same. It goes down, the wave goes down, but still same. I'm going to take from here until here is one oscillation. Okay, one oscillation, and the rest is from here all the way to here. This is 3/4, right? 3/4. 3/4 oscillation. So this is 1.75. 1 plus 3/4, so 1.75. And we divide by the time it takes for this 1.75. So it's 0.75. 0. Oh yeah, one thing I forgot to tell you. This one have to be careful with the unit. Okay, so this is minute, right? The timer is in minute. So this one, here's a little mistake here. So 1.2, I have to change it to minute. 在 example 5. Okay, example 5那边那个时间是 in minute，所以有时候考试也是他们会这样子，要注意那个unit, alright, the unit. So if it's in minute, then you have to change it to second. So 1.2 you times 60, 72 second, right? 72. Excuse me. 所以1.25除72， 0.02 hertz. 0.02 hertz. So this one I change it. 0.02 hertz. Okay, the last one, same. Last one is also in minute. So 1.75 divided by 0.75 minute. So you change to second, 45 seconds. Yep, so you get 0.04 hertz. Okay, so that one is how we calculate frequency. Remember that one, okay? How we calculate frequency. So next one is to calculate speed of the wave. Speed of the wave. Example 7. Okay, here you got two graphs. 在 wave 里面是 for graph the wave wave 的 graph 它有两种一个是 displacement time， 一个是 displacement distance。displacement time 是给你用来算 frequency 的 ，displacement distance 是给你用来算wavelength。Okay, wavelength. So from the first graph we find the frequency first. Okay, calculate the speed of the wave 我们只有一个 formula for here in the wave you learn about V equals to F lambda. OK， 那这个 formula 是用来算 wave 的 speed。F 就是 frequency， lambda 就是 wavelength。OK，V 是 the speed of the wave. So whenever you have the frequency and the wavelength, then you can find the speed. Okay, so let's find the frequency from the graph here. So how many vibrations? How many complete oscillations? One sine graph, one complete, 2 and 3. So 3 in 0.6 second. Right, so 3 divided by 0.6 second divided by 0.6. So that is 5 hertz. Okay, 5 hertz. 5 hertz, and then the wavelength. So the wavelength here is, now wavelength is from crest to crest or trough to trough. Okay, the length of one oscillation. Now here you have 3 complete oscillation, right? 3 complete oscillation, and overall the length is 15 cm. So you have to take this one and divide it by 3. Okay, because wavelength is only from the length between one oscillation. So 15 divided by 3. So one wavelength, the wavelength is equals to 5 cm. 5 cm. Okay, so 5 cm. Remember, you have to change it to meter because frequency and the wavelength, the unit is in the SI unit. Okay, it's in the SI unit. So frequency is in hertz, right? Frequency, you have to make sure the time is in second. The time is in second, only then you can put hertz. Okay, so 5 hertz 乘5 hertz 乘 5 times 5 cm, so you change to meters, so 0.05 equals 0.25 meter slash second. That's the answer. Okay, so that's the speed of the wave in meter per second, 0.25 meter in 1 second. Okay, you can take a screenshot and then I erase this one. I go to the next question. Okay, example 8. A transverse wave, okay, this is again to calculate the speed. A transverse wave with a wavelength of 4 travels at a speed of 20. What is the frequency of the wave? So pretty straightforward. V equals to F lambda. Okay, be careful with the unit. V is 20 cm per second, right? 20 cm per second. So I put in 20 equals to F lambda. I can just use 4 cm because it is in cm per second, right? 4 cm. So F equals to 5 hertz. That's it. Okay, that's it for this one. Okay, so take this down and I'll go to the next part of the session lesson. OK， 来，我们继续啊。OK， 来，今天我讲到 oscillation, natural frequency, and also resonance. Okay, and hopefully if we still have time, I'll go into the refraction and reflection of waves. So we'll finish it as quickly as possible. Okay, and we'll take the time to do some revision on the previous chapters if we have time. So I'll try my best to finish it. Okay, oscillation, natural frequency, and resonance. Okay， 首先你要先明白啊 ，OK，natural frequency， 因为很多人会弄乱，不知道什么是 natural frequency。那首先我们先讲 oscillation 先 ，OK，oscillation 呢，你有2种 oscillation。你在你的书里面呢，他会跟你讲，你有2种，一个是 free oscillation， 然后一个是 forced oscillation。OK， 那我先讲 free oscillation 先。free oscillation 就是如果你看那个 definition 它是讲 without external force， 对不对？可是什么意思？比如说，我给你一个 scenario， Okay, let's say we have a pendulum. Now this pendulums are swinging pendulum. Okay, let's say if I hold the pendulum at this point. Okay, let me draw it nice, nice a bit. Okay, the pendulum, I hold it here. Okay, I displace it at a certain height, a certain height. So maybe let's say this is the height h1. Okay, whatever the height, h1. Now, if I hold it at h1 and then I let go, so what happens is you see is oscillation, right? So this one will produce oscillation, so it will start to swing here and swing back, right? So that's called one complete oscillation. As it swings back to the original position, that is one complete oscillation. Now, free oscillation 呢，就是讲我放手的时候是，我给它自己 swing 到它停。OK， 我给它自己 swing 到它停，在之间是我没有去 push 它，或者我没有去 exert any force on the ball on the pendulum. Okay, I just let it swing by itself and I let it stop until it stops. Okay, now that is the oscillation. If we take into account the air friction, right? In reality, right, you have air friction, so the pendulum will eventually come to a stop, correct? So if you let it swing in vacuum in outer space, it will not stop, right? Because there will be no energy loss, no friction. Okay, so that is free oscillation. Free oscillation is I let it swing by itself without giving any force. Okay, without giving any force. Now 在 air 里面呢，就在我们的in our reality, like there's air friction, right? So that is not a perfect free oscillation. That is not a perfect free oscillation. Why? It's because you have air friction, right? You have air friction. So the air is creating the force to maybe stop the swinging, slow down the swinging. So there is some external force there. 所以那个不是 perfect free oscillation. The perfect free oscillation would be in the vacuum. All right, would be in the vacuum. Now, 这个如果你给这个 pendulum swing 的时候是，你可以算它的 frequency 对吗 ？OK， 我们可以算它的 frequency. Again, the frequency is equals to the number of oscillation to the time 对吗 ？OK， 意思说我给它 swing 了，然后我拿我的 stopwatch， 我算 OK 1秒，我看它 swing 多少次。比如说，如果它 swing 1秒 ，OK 一次，这样我的 frequency 就是1 hertz。Okay, so remember, this one frequency is the, okay, I write this down for you, a number of oscillation in 1 second. So if 1 hertz means one complete cycle in just 1 second. Okay, you start your stopwatch 1 second, then it comes back to the original position. So that is the frequency in the free oscillation. Okay, in the free oscillation. Now, 这个 frequency 呢？The frequency in the free oscillation, we call it what? We call this frequency as the natural. This is the natural frequency. Meaning that the frequency of the object when it is left to vibrate by itself without extra or external force disturbing it. That is the natural frequency. Okay, imagine you take a pendulum, 你去the space, you go to the outer space, you go to outer space along with your pendulum and you displace it, you let it swing. Okay, and then you calculate the frequency. That frequency is the natural frequency. Okay, that is the natural frequency. Now, if I, let's say the second, if I bring it higher, okay, let me draw it out. The same pendulum, okay, I take the same pendulum, but now I displace it higher. I hold it up higher before I let go. Okay, so it's higher here, and the height has now increased. This h, maybe we call it h2. H2 is higher. Okay, h2 higher now. If I let it go, I swing here, I let it go, and it swings, right? It swings. Will the frequency change? 它的 frequency 会变吗？想一下。如果我用同样的 pendulum， 然后同样的 length of the wire, I let it swing at a greater height. The frequency will not change. Okay, the frequency right down here will be the same for H1 and H2. No matter how you displace it, okay, the frequency will still be the same because that is the natural frequency. Only if you change the length of the pendulum. 如果你增加那个 pendulum 的 length， 或者你减少那个 length 这样你就会 affect 它的 natural frequency， 它就会有另外的 natural frequency。因为如果你一换那个 length of the cable，then 我们是 consider 它是另外一个东西，另外一个pendulum。Okay, so for the same pendulum, for the same type of pendulum, the natural frequency will always be the same. OK， 所以如果你把它拉上一点，你从这边H2你 drop 它 swing， 它的 frequency 也是一样，也是会在1秒里面算到一个 cycle 的。OK， 可是它看起来好像会跌到很快，对不对？因为它会it has a longer distance to travel, right? Sometimes you see if you swing it from H2, it will move faster, right? It will move faster because it has a longer distance to cover. That's why it moves faster. But overall, the frequency will still be the same. Okay, in 1 second, it will still be 1 cycle. Now, this is when we use the same thing. So this is natural frequency. So in other words, we said natural frequency. Frequency, if I write down, it is the frequency when an object not subjected to continuous or repeated external force. Okay, so after I let go the pendulum, I never touch it. I never touch it. Okay, and if we ignore the air friction, okay, so that frequency is the natural frequency. We're not subjected to continuous or repeated external force. Okay, repeated means I keep pushing it, no. Okay, now that one is for free oscillation. Okay, free oscillation. So natural frequency is any object's frequency vibrating in free oscillation. So 每一个 object 你看你周围的每一个 object 都有certain vibration， 可是你看不到啦。比如说你看那个东西，你的笔在你的桌上 ，of course 它不会it's not observable the vibration, right? But it's still it has a tendency to vibrate. Alright, it has a tendency to vibrate. So any object with elastic material, when they are disturbed, they vibrate, right? And as they vibrate in a certain frequency. That is their own natural frequency. Okay, so this is very important. So in exam, they will ask you what is natural frequency. Now, every object, they will vibrate differently at their own natural frequency. That is why 如果你弄跌一个let's say 你丢一个 spanner 去地上，还有你丢一个 baseball 棍在地上，你会听到有不同的声音。你丢 spanner 汤，你丢一个 baseball 棍咚这样子不同的一个声音是因为它们不同的 frequency. Alright, they vibrate at different frequency. That's why they produce different sound. Okay, so understand that natural frequency. Every object has their own unique natural frequency. Now that is for free oscillation. Now next one we look at the forced oscillation. Forced oscillation 呢，就是比如说我们用同样的 example 啦 ，OK， 我们有一个 pendulum， we have one pendulum, and then the same thing the same pendulum I bring it to H1, a certain height. Now this time, when I let go, I let it swing. Now every time it swings back here, so okay, let's say it swings here, and then it swings back here, right? The moment it starts to swing to the right again, I give it a push. Okay, every time as it swings back, okay, I give it a push every time. Okay, so I'm constantly giving it external force, right? I'm constantly giving it a continuous push. Okay, so here I write down here, continuous push. Okay, so if I constantly give it a continuous push, then what happens is that this spring, when you calculate the frequency, the vibration frequency, it is not equals to the natural frequency anymore because you are disturbing it. Okay, it's still vibrating. Yes, it's still vibrating, but it's not vibrating in its own frequency. Okay, now 这个 force oscillation 呢，不一定是你 push 它的 ，OK， 不一定是 directly from external force 的，它可以是两个 object 放在一起，比如说这样子，我有一个 tuning fork 啊，let's say I have a tuning fork. So in case if you don't know what is tuning fork, it's kind of like a something that used to tune the musical instrument. Okay, they strike the tuning fork and then they listen to the note, they tune the guitar or the piano, whatever. Okay, this is the tuning fork. So as you strike the tuning fork, what happens? The tuning fork vibrates, right? It vibrates. So the tuning fork vibrates, and this is called the free oscillation, right? Free oscillation, because as you strike it and you never touch it, you let it vibrate. Oscillation. Now, what happens if you mount this tuning fork with a wooden block? Okay, let's say I do it like this. Okay, this is the tuning fork, and I attach it to a block. Okay, so this is any wooden material, wooden block. Okay, so this one, as you strike the tuning fork, what happens? It will vibrate, right? It will vibrate. So the tuning fork vibrates, and it will cause the wooden block to vibrate as well. Okay, so here you have two different materials, correct? You have the tuning fork, you have the wooden block, but they are attached together, right? As you strike the tuning fork, it vibrates, it causes the wooden block to vibrate, and as the wooden block vibrate, right, it will disturb the vibration of the tuning fork again because they are in touch with each other. So this is also we call force vibration. The point is, 不一定是我 push 它，那个才叫 force vibration。如果你有两个 vibrating object 放在一起啊 ，in touch with each other, they will disturb each other also. So that is also considered a force vibration. Okay, so that is also considered a force vibration. So in fact, you will see 啊，如果你把这个 tuning fork 粘在那个 wooden block 啊，当你一打它的时候，你会发现到它的声音会比较大声 ，compared to 如果你没有放那个 wooden block。Okay, now that one later will come to that. That is something called the resonance. Okay, so the second one, the second diagram, this one, as you strike it, you will hear louder sound. Same concept with the guitar. Okay, the guitar string 啊，guitar string，如果你只是单单plug 那个 string 啊，没有那个 guitar 的身体的，你听不到声音的，你听到很小很小的声音。可是那个 string 需要那个 guitar 的身体一起，因为 as the string vibrates, it will cause the guitar's body to vibrate also. Alright, it will cause the guitar body to vibrate, and then as it vibrates, that is also one of the force oscillation. Okay, that is also force oscillation. Okay, so understand force and free oscillation in this. Here I just want to clarify these two, force and free oscillation. So in summary, so free oscillation is I don't give any force. It just vibrates until it stops. It just do its own thing. Force oscillation is when I disturb it. When I disturb it, I continue give the push. Okay, every time the pendulum swings up, I continue to push it. Okay, or it can be any two vibrating objects that is placed together to each other. That is also considered force oscillation. Okay, now 我剩下1分钟，我再 create 那个 link，然后你再 join，然后我们再